Alright, so here we are with section 1.5, which was the last section for this week, and let's see whether we can cover this slide. Now, we are still with the line, slope. Don't forget, we are again starting from the section 1.2. We are still talking about the equation, functions, line, and slopes. Now here, we'll be a little bit more, we'll explore the line and slopes a little bit more than what we did in the last section. Now first we'll look at the parallel and perpendicular lines. Is anyone here who do not know what are the perpendicular lines? When two lines intersect each other at 90 degree, right? They're perpendicular to each other, and we definitely know the parallel lines for sure, right? Now, one of the interesting thing, the slope tells us that whenever we have two parallel lines, doesn't matter where they are, as long as they are parallel, their slope are same, equal. So just by looking at the slope, you will be able to answer that question. Let's say I give you two equations, okay, and I ask, are they parallel? The answer is going to be a yes/no question, okay. So all you need to do is, you can change the equation to mx plus b form, and right away you will know the slope, right? When you see that they both have the same slope. For an example here, look at this, a red line and blue line, and let's say we have two equations for them. All we did is we just converted the equation into their y equal to mx plus b form, and then we found that they have the same slope. Okay. Now, that's what exactly is written here, that if two non-vertical lines are parallel, remember again, as I said, in general, when you talk about the lines, we exclude the vertical and horizontal lines because they have a little bit different properties than the regular lines. So if they have the same slope, if two distinct non-vertical lines have the same slope, they are parallel. So exactly the same thing, but in the reverse way. Two distinct vertical lines with both undefined slopes are parallel. Because you know that all the vertical lines of the world will be parallel, right? Because each of those lines is parallel to y-axis, right? They're parallel themselves, so that's already implied. We know that. So here we have an interesting problem. Look at this problem carefully. Let's say we have an equation of a line. Read the question. Find a line. So basically we have to find an equation of a line which is parallel to this line. So what it is, we are given a line, okay, and we are also given a point. Now the question is asking, can you find another line, that means another equation of a line, which is parallel to this line and passing through this point? So you have to basically understand what is the inherent message of the question. The first message is, since you are given a line which is parallel, so you will know the slope from there because all the parallel lines have the same slope. You see what I'm saying? So you are given one equation, okay? So what we did is, look at the first couple of steps. What we did is, given the equation, we changed the equation into mx plus b form. Do you see this form? Do you recognize that this is mx plus b form? Look at this, y equal to m, so m is 1 over 6, x plus b, which is 4 over 3. So why we did that? Because we need to know the slope of the new line, and we know that since both of the lines are parallel, the new line will have the same slope, which will be 1 over 6. So once we have it, we know that this is going to be the slope for our new line. Now, at this point, what we know about the new line? We know its slope, which is 1 over 6, and we also know that Look at the question. What do you know? Because you always want to ask the question yourself, what we know about the line. We know the slope. We also know one point of the line, because the question is claiming that the that line will pass through -2, 3. So you are basically done, because all you need is one point and the slope. What form you are going to use? Think about the form. What form you are going to use? Point slope form. Let me write that form. Y minus y1 equal to m times x minus x1. This was the form, right? Remember from the last section. What do we need it? We need the slope, right? And we got that, which is 1/6. Because we have another line which is parallel to this, and that line has a slope of 1/6. So we know that the slope of this line is going to be 1/6, right? And we also know that this line will be passing through -2, 3, right? So this is going to be your -2, and this is going to be your 3, and this is going to be your 1/6. We are all set. You don't need any other information. That's it. Look at how simple it is. But you know, we need some practice to understand how to understand the given information in the question. Okay. Let's look at some more interesting problem. Now, this is another problem. So, similar problem. You are given a line, and you have to find another line which is parallel to this, and which is passing through 5, 2. Again, all you need is you have to tweak this equation a little bit to go to this format, right? Y equal to mx plus b form, so that you will know what is the slope. Once you know the slope, you know that that will be the slope for your new equation, right? Because both of the lines are parallel. And you know that the new line will be passing through 5, 2. Again, you know all the information right now for the point slope form equation. I'm sorry, for point slope form. Any question? So one of my teacher, when I was a student, told me that when nobody responds in your class, there might be two cases. One is everybody understands everything, and the other one is nobody understands anything. So I'm not sure which one we are here, which one we are encountering. But remember, you always want to ask the question, because as you have seen, just whatever we have learned in the last section, we are just applying it here. It's so quick that you always want to make sure that you understand in the class, because we don't have that much time really to spend, because we don't have even like 24 hours marginally between classes except the weekends. See, this, as I said before, the form is nothing. It depends on what information you know. Based on that, you will choose what form is good for this question. Now, we choose this form because, look at this, what we have. We have M. We have 1 point. If you think about that, you will see this is the only form which is suitable for that. Yeah. Yeah. Because at the end, see, when the question is saying find a line, that means basically find the equation of a line, right? Here it's mentioned, write the equation. That means it's the equation of the line. And also here, another interesting thing is, look at this. There is a little bit trick here. You are finding the equation using this form, right? But look at the equation. Look at the question. Question is saying write the equation in slope-intercept form. This is not the slope-intercept form, right? You will find the equation using this form, but at the end, you will write the equation in this form. This is the slope-intercept form, right? The reason why this is called slope-intercept, look at this. There is a slope, there is an intercept. That's why this is called slope-intercept form. This is called point-intercept form. Why? Point-slope form, because there is a slope, there is a point. It's one point, x1, y1. So I think, anyone has any question about this question? This is the same question. We just, same question. We are doing some practice. Now, one more thing here is, as I said, just looking at the slope, we know that the lines are parallel. At the same time, just looking at the slope, we know that the lines are perpendicular to each other. Perpendicular means they intersect, just like here. Look at the red line and the blue line. They intersected at 90 degrees, right? Now, you will know it from their slope. How do you know it? If you multiply their slope and the lines are perpendicular, then the result of the multiplication will be always -1. So as long as their slopes, multiplications means product. We know that, right? The product of slope. So let's say one slope is m1 and other slope is m2, and you multiply m1 times m2, you will always end up with -1 if they are perpendicular. So there might be quite interesting question. For an example, let's say you are given two equations and they will ask you, are the lines perpendicular? How to solve it? Just convert the equation into slope-intercept form, then you will know the slope of both lines, right? Multiply their slope and see whether that is -1. If it is -1, yes, they are perpendicular. If it is not, no, they are not. Okay. And again, I think number 3 is like, we already know that any horizontal line is perpendicular to any vertical line. I think we know that. It's just true for, it's very generic, but still we just want to make sure we don't have any confusion. So here we have a new interesting problem which is extremely similar to the last one. Remember, in the last problem, what we did, we were given an equation, we are given a point, and the question was asking, can you draw a line which is parallel to this and passing through this point? Now here, it's a similar problem, but you are still given an equation and a point, but the question is asking, can you draw a line which is perpendicular to this and passing through the point? For an example, let me show you exactly what the question is asking. For an example, let's say you are given a line, this red line. Okay, this is already given. Okay, you are also given a point. This is what you are given, and they are asking, can you tell us what will be the equation of this green line? Because this green line is intersecting this at 90 degrees and at the same time passing through this point, right? How do you do it? It's extremely simple, because you just first have to get the slope of the red line. Equation is given. Equation of the red line is already given, right? Now, look at the equation carefully. What we did is we just tweaked and we just converted the equation into this form. Because this form is extremely simple to convert, and once you have it, you will know the m right away. Okay? Now once we did that, this is the m, right? Which is 1/6. Now, you know that the new line that you are trying to find is perpendicular to this. Right? In case of the perpendicular lines, their slopes, the product of the slope is -1. Now how to do that? All you need to do is, you have to find the reciprocal of 1/6. What is the reciprocal? So 1/6, the reciprocal of 1/6 is what? 6, just 6, right? Because you again do the reverse. So basically you just convert you just made the numerator denominator and denominator numerator. So 1/6, if you just make 6 is denominator here, so make it numerator, 1 will be denominator, it will be just 6, right? So you will basically do the reciprocal and put a negative sign. That's what we mentioned here. Use the negative reciprocal slope. So what will be the slope of the new line then? Negative 6, because you will do the reciprocal first. It's 1 over 6. Do the reciprocal, it will be 6. Put a negative sign, negative 6. That will be 6 only, because negative negative makes a positive. Now his question was, what happens if the first slope is negative 1 over 6? Then do the reciprocal first, it will be what? Negative 6, right? If it is, let's say, negative 1 over 6, once you do the reciprocal, it will be negative 6, right? And then you put another negative sign, it will be just positive 6, right? Negative negative makes a positive. So, you know. So here, so from this information, we found the slope of the new line, which is negative 6. And then we are again using the point slope equation. We know the point, right? I'm saying this point, the red point here. We know this point, and we know that the line will be passing through this point, right? So we just, you know, this is minus 2, 3. Now you're done. That's it. So we are just trying to show you that how some information is, you know, how to read the information. The question is given in a little bit different form, but at the end, you know that you have to find the slope, you have to find points. Either you are given something or you have to find something, and you will have to feed those information into the form you know. This is an example of that. So I think we can find. So all you need to do is, from the equation given, you will find the slope first, and then you take the reciprocal, do the negative, because the lines are perpendicular, right? For an example, let's say what will be the slope for the first? What will be the slope of the equation? Let's try this. Let's see. I have some. Okay, let's try this. So equation is 3x minus 4y equals to 12. I'm just doing it a little bit fast, so I think we know how to do that. But so I'm just dividing by 4, so it will be like 3 over 4 minus 3. Oh, x. All right. So at this point, what is the slope? 3 over 4, right? Now, what will be the slope of the new line? You will do the reciprocal, right? Which will be 4 over 3, and you put a negative sign. So this is going to be the slope for the new line. And the new line is passing through where? 5, 2, right? So let me write the equation for that new line. Y minus 2 equal to m times x minus 5. You're all set. Here, right? What do you mean by the whole thing? When you took the bracket out, this term will be. Yes. Because you know, when you have two negative signs, that will be positive. So negative is always going to be one negative sign. Either that is on denominator or numerator that is negative. Yeah. Now, any question from here? All right. So one new information for you is, so far we have discussed with slope, but slope is also used to explain the rate of change, because as you have seen in the equation of the slope, that slope is basically telling you that how the y is changing with respect to x. Because you know what is the equation of the slope? y2 minus y1, y2 minus y1 over x2 minus x1. That basically will tell you that how the y is changing with respect to x. So in a lot of places, people only use slope to understand the behavior of some event, some graph. Even if that graph is not a straight line, still people want to try the slope. Okay, so we'll see some of those examples. So now we are trying to define the slope as a ratio of change in y with respect to x. Okay, you see, sometime in math people use these signs. This is a delta. I'm not sure whether you have seen it before, but the delta is used to denote the change in y. So this means change in y over change in x. Okay, delta x means change in y. As the change in x, delta y means change in y. And again, we have the equation, we know that. So for an example here, let's say this is a real life problem we gave you, and let's say this is some years after 1997, and this graph is telling you that what is the percentage of US adults who smoke cigarettes X years after 1997. You see the line is what kind of function it is, decreasing, increasing, constant. It's a decreasing one, right? So that means that the rate of the adults smoking is decreasing. Okay, now this is one interesting thing. So let's say you are given 2 years, which is 0. 0 means is basically 1997, right? And 10 years after, which is 2007, right? And they gave you that, okay, in 1997, probably along this line we have number of adults maybe in 1,000, let's say, okay? So 24.7 thousand is basically 24.7 times thousands. And let's say now this is 19.5, and let's say you want to know what is the rate. We know that that is decreasing, right? But what is the rate of decreasing? So we'll know it just from the slope. All you need to do is you have 2 points, right? Just find the slope. Once you know the slope, look at this. We know the slope, which is minus 0.52. And how to explain the slope? What is the meaning? The meaning is the percentage of US adult cigarette smoker is decreasing by this percent. This percent what? Each year. Because it's with respect to x. And x is defined per year, right? So every year, 0.52% of US smoker is getting rid of cigarettes, let's say. Okay. So, and since the line is linear, so the rate is constant. I'm saying decreasing rate is constant. So it's constantly decreasing. Okay. So this is again is some kind of some other way of using slope and some other feature of slope that you can use to understand the behavior of something else. And this is again something else similar to that along that line. Average rate of change of a function. So for an example, let's say now you see here the original line is the blue line. You see the blue line here? That is your line. As you can see from this line, this is not a straight line. Okay, what does it mean? First of all, it means that it does not have a constant slope. You know, in our straight line, we have only one slope for the line. But interesting is when the line is not straight, we have different slopes in different points. We'll discuss about that later. But for an example, let's say at this point, you see here, the function is basically changing at every point. Why is that? Because at every point, you see the function is basically, for x1, f1, the function is changing, and you can find that using the slope. You see, this is still the slope, because look at this f of x2, that is basically what? y2, right? And f of x1 is y1, so still we are doing the slope. So let's say for an example, we'll be looking at the same thing. Let's say you have 2 points. If the function is not a straight line, the average rate of change between any 2 points here, let's say the blue point and green point, is the slope of the line containing that 2 points. So since we have 2 points, first of all we can draw a line, right? We have drawn a line. Look at the yellow line, that is the line. Once we have the draw line, this line is called the second line, And once we have that line, we can just find the slope of that line. As long as we have a line, we can find the slope. And since we know 2 points, and there is still x and y, because y is written as a function, but that's the same thing, right? So here is an example. Let's say these are 2 points you know. So you know exactly this is x1, y1, let's say this is x2, y2, or whatever, however you assume that. So using that, you can find the slope, which is 1. So the rate of change is here 1. Another example, again, look at the red and blue functions, because we just want to make sure that which one we used as red and which one is it. But remember, you can use the vice versa. There is no order. Remember, we can just use anything, any point as x1, y1, other point as x2, y2. So we are still doing the same, and we're just trying to find the slope. In this case, so basically that's how the function is changing. That's called the rate of change of the function, average rate of change of the function. But remember, when you are taking the average rate of change, depends on which 2 points you are talking about. Because you know, all of these here, example, look at this example. We are basically taking the same line, but points are different. That's why even the rate is different. You see the rate is different? But still the original line, which is the red line, is still same. But every time what is different is we are choosing 2 different points. But whenever you choose 2 different points, your green line is getting changed, right? So your slope is getting changed. So average rate is changing because you are choosing 2 different points. So here, this is another lesson for us, that in case of the curves, not the straight line, rate of change is different between any 2 different points. It depends on which 2 points you are choosing. Okay, it depends on that. Now, these are some different examples. Let's say, see, these are the 3 lines we have drawn so far. The left one is the first one is a dark green, and then cyan, and then light green. I'm not sure, probably is this the cyan or something close to blue, right? Let's say. So these are 3 data you have, and as you see, slope of the 3 pair is different because our 3 set of points were different. But the first point was same, but the second point was different in 3 different points. That's why we had the different straight lines, different rate. Now what is the explanation? How the slope changes dependent on the point that we choose, because this function is a curve, not a line. Exactly that's what we wanted to explain. And the average rate of change varies depending upon which points you are choosing. Okay. Here we have an example. I think you can try based on the function, because all you need to do is, let's say you are given x1 and x2. For x1, you can find what? F of x1, which will be y. For x2, you can again find f of x2. To find the slope, you just need what? x1, x2, f of x1, f of x2. So you have all those 4. You can find the slope. So for all these 3 cases, this is just for you. So these are some points. We did some calculation here. So this is f of x1, f of x2, and we did that. And here we tried for these points. Again, everything is on the same line, but we are choosing different points, and we are trying to show you that how the rates are changing. Look at this. Everything is in the same line, but in the first one we got the slope 19. Second one we got the rate 37. In the third one, the rate is 4. You see the difference. Same line, but the line is not straight line. So that's why, based on how you are choosing the 2 points, your slopes are different. Okay. But still, we have the same basic equation. This is an example. This is an equation. Okay, example for that equation. How far we are? Yeah, we are close.
I have a question not really regarding this
Sure.
class, but more calculus. Calculus, you're more finding the instantaneous rate of change, correct?
Yeah.
So you would just take that 1 point?
We are going towards that direction.
Okay.
Yeah, because when both of these points are extremely close.
Right. And then you draw the tangent line, correct?
Yeah.
And when you find the f of x of that tangent line, and
Yeah.
find the derivative.
That's exactly the slope.
Yeah. So, but that would still be the instantaneous rate of change at that point?
Yes. Yeah.
Okay. But you would find that.
How you can find it only one point? That what is your question?
Well, then you would draw the tangent line, right? And then you would,
Yeah.
from that tangent line, you do the function just like we did in this class.
Yeah.
You know, put it into the f of x. And then once you
But
get that, you take the
interesting
derivative.
is if you look at the definition of that, it's called differentiation, right? Remember the ddx of something?
Yeah.
Yeah, if you look at the definition of that, you will see that that function is defined in terms of the difference quotient. Remember we talked about the difference quotient yesterday? See, based on difference quotient, and in the difference quotient, if you assume that the h is extremely close to 0, then people assume that there's only 1 point. That's exactly not 1 point. There is still covering multiple points. But when h is very close to 0, it assumes like you are basically taking the tangent in 1 point. But think about that. Can you draw a line in 1 point? You cannot. But there are multiple points, but they are so close that you can assume that it's 1 point. You are not basically drawing the tangent in 2 points.